Okay, class, so we have one last topic that we need to talk about with factoring. And it isn't necessarily that it's new, it's just taking all the information that we've learned and sort of continuing to put it together. So today we're going to talk about how we can factor completely. Okay. And just like when we prime factor, right? So if we were asked to prime factor 20, we would split 20 into maybe 2 and 10, but we wouldn't stop there. We would keep factoring more if there's more that we're able to do. Right? That same idea we want to use today when we're factoring polynomials. So we're sticking to that same sort of checklist of ideas. That the first thing that we're going to do is we're going to look for a GCF. So if there's a GCF, we're going to factor that out. Okay, so we're going to that was terrible writing. We're going to factor out a GCF if we can. Okay, then we're going to count the number of terms. If it's 4 terms, we're going to do grouping. If it's 3 terms, we're going to do a trinomial. If it's 2 terms, we're going to do a special case. Now, just to make sure that we actually get it factored completely and that we didn't miss anything, our last step is going to be to check for any other GCF in any place. Okay, we want to make sure we didn't actually miss a GCF anywhere. Okay, so instead of just factoring once and being done, we might need to factor twice before we're done. So for example, let's say we want to factor 2x squared plus 14x plus 24. Now, we might look at this right off the bat and go, oh, it's 3 terms, it's a trinomial. I can multiply 2 times 24 and start making my list. Your math wouldn't be wrong. However, the problem is that you're going to end up with large numbers, at least larger numbers than you would need to use. So instead, it's always in our best interest to check for that GCF first. So we're going to ask ourselves, is there a GCF? Can we think of a number that will go into 2, 14, and 24? And hopefully we say, yes, I can think of a number. It's 2. They do not all have the x, so I can't pull out a variable there. So I'll get 2, right? I'm dividing it out, and then I'll have x squared plus 7x plus 12, right? So I factored out a GCF. Now, instead of just circling this in and saying, yep, check, I'm done. Okay, now I'm going to look right in here. I'm going to say, okay, is there anything else that I can do? So now I want to look at these 3 terms and go, okay, now I want to consider a trinomial. So I'm ignoring that 2 out in front. I'm just looking at x squared plus 7x plus 12. It's 3 terms. Okay, so let me try and factor it as a trinomial. So I'm going to take 1 times 12. And I'm going to start making my list. 1 and 12, 2 and 6, 3 and 4. Okay, and I want to check and see if any of those add up to 7, which 3 plus 4 adds up to 7. Now, because this had a 1, I can use the shortcut. So this factors into an x plus 3 times an x plus 4. Can't forget that that 2 is still part of the problem, so that 2 stays out in front. I don't have any other GCF when I check, so my answer is done. Now, sometimes our hand will be forced and we'll have to factor out a GCF first. So let's say we're given something like 18a squared minus 50. Okay, so if we look at this problem, it's two terms. And so in our brains, we might go, oh, maybe this is a special case. The problem is that 50 is not a perfect square, nor is 18, right? There isn't a number times itself that gives us 50. There isn't a number times itself that gives us 18. So this right now is not a special case. Okay, but again, if our first step is always to check and see if there's a GCF, right? This does have a GCF. What goes into 18? That will also go into 50. That's a 2, so we can factor out a 2. We factor that 2 out, it will leave us with a 9a squared minus 25. Now again, we are then going to look inside the parentheses, and we're going to count the number of terms. Okay, so that has 2 terms, so let's check and see if this is a special case. Well, it is, right? 3 times 3 gives us 9. 5 times 5 gives us 25. And then we just have to remember that we're taking half of the exponent. Okay, so half of that a squared gives us an a. If we remember a special case, right, we're writing this into 2 binomials. Okay, 2 binomials where the term that's first goes first. The term that's second has to go second, so no changing that order up. One gets addition and one gets subtraction. It doesn't matter which one you give addition and which one you give subtraction, as long as you give one of each. Then we just can't forget that that 2 is sitting out in front. We don't see any other GCFs. So we know that we are done. Okay. I want to look at one more here. The most common place that students will look at a problem, okay, and they'll miss the GCF is if it's 4 terms. So let's say we're given 12x to the third minus 8x squared, minus 18x squared minus 8x plus 12. Okay, and a lot of times students will look at this and go, oh, look, it's 4 terms. I'm going to chop this in half. So let's just say that that's what you do first. You forget to ask yourself if there's a GCF. And so you go to factor out the GCF on the left. Okay, so a number that will go into 12, that will also go into 18. We pull out a 6. They both have the variable. The smaller exponent is 2. Okay, so I divide that out. And I have a 6x squared times a 2x minus 3. And then I go over to the right-hand side. And even if I use the trick, right, it's fine, of dividing here and here. I get a GCF of 4. Now remember, this is negative, so that means it's negative 4. A negative divided by negative is a positive. Positive divided by negative is a negative. And so we go into our final answer of 6x squared minus 4 times 2x minus 3. Now, the problem here is that this isn't actually factored completely. And the reason why is because right here, right, is there still a GCF? And the answer is yes, right? If we look at that 6x squared minus 4, we could still factor out a GCF of 2. And so if we pull out that 2, that 2x minus 3 just stays. We didn't change anything about it. And so here is our answer. Now, you wouldn't have to notice that in the end if up here at the very start, you realize that this all 4 pieces had a GCF of 2 to start with. You could have pulled out that 2 in step 1 and had smaller numbers. But what I want you to understand is that it's okay if you accidentally miss it on any problem. You could get down to the very end and realize, oh, wait a minute, I still have a GCF, and pull that out at the end and still get the exact same answer.